I'm too tired to do any more real work tonight, and I think we've gotten to the point where the problems we're doing are actually sufficiently fun and addictive that I just want to do them for my own amusement. So I'm going to solve some contest math problems that use some of the trig stuff we've done, mostly just because I enjoy it, and if you enjoy it as well, then you can watch them just for fun, and if not, then you can skip them. But anyway, this question is from Lehigh 2017, I think. So this is the Lehigh University math competition, which is a feeder round into the ARML competition. And so this was one of their questions, number 26. So towards the end, the questions get harder. But anyway, the question asks, if sine x plus cosine x is a third for some x, then it asks, what is the value of sine cubed x plus cosine cubed of x? Okay, so the gut reaction should be whenever you see a sum of cubes, you should kind of automatically vomit this sum of cubes thing. So we know that for any a and b, this thing factors as a plus b, a squared minus ab plus b squared. So I think this was on p set 0. I asked you to know how to derive this, but you can kind of just show it by expanding out and seeing that it works. So this means that in this particular case, here a, for the value, the thing we want to compute is this sine cubed plus cosine cubed. So here a is sine x and b is cosine x. So applying the formula and switching colors, in that case, we find, so sine cubed x plus cosine cubed x should be, well, we get the a plus b piece, so that's sine x plus cosine x. And then we get sine squared x minus a cross term, that sine x cosine x is going to be a bit of a pain in a moment, but let's just go onwards, plus cosine cubed of x. So now there should be alarm bells going off in your brain, because whenever you see a sum that includes sine squared and cosine squared, you should immediately want to genocide those terms. So you combine these because for any x, the sum of those two is going to be 1. So we know what those terms are. The sine squared and the cosine squared give us a 1. This thing, well, we know what sine x plus cosine x is because that was given up here way back in the problem statement. Sine x plus cosine x is a third. So we know this is a third. And the thing on the left side is this is what we want. So this is the answer, the desired quantity. So you can see we know almost everything. We just need this weird cross term, this minus sine x cosine x, which at the moment seems unknown. But it's actually not that unknown. We can figure out what that is. So I mean, we just compute. In general, if you want to compute a cross term, you think that those things come from foiling out a square, right? So you can always take the quantity sine x plus cosine x squared, and that's going to give you the desired cross term. So what do I mean by that? I mean, let's think about sine x plus cosine x squared. Well, we know that the thing inside the parentheses, sine x plus cosine x, well, that's just a third. So if we square that, we know that's a ninth. But on the other hand, we can FOIL it out and get sine squared x plus 2 sine x cosine x plus cosine squared of x. And again, the genocide is coming because we know that sine squared plus cosine squared equals 1, right? So those are these two in pink. So I'm just going to go to the next line and insert that genocide. So 1/9 now equals 1 plus 2 sine x cosine x. And if I can do arithmetic in my head, I believe 1/9 minus 1 is minus 8/9, divided by 2 is minus 4/9 is sine x cosine x. So that's the thing, the missing term. So we take this minus 4/9, which we've just computed, and I should switch colors again to maybe this salmon color. So this minus 4/9 is going to go up here, and let's just be careful about the minus sign because there's an overall minus for this minus sine x cosine x, but that minus combines with this minus sign to give us a positive 4/9. So overall, this is a positive 4/9. So at the end of the day, the thing we want to compute is going to be 1/3 times 1 plus 4/9. So this is equal to 1/3 times Well, 1 is 9/9. 9/9 plus 4/9 is 13/9. So 13/9. So that should be 13 over 27. So that's the answer, actually. That if sine x plus cosine x is a third, sine cubed plus cosine cubed is 13/27. Is that actually? Yeah, that's the answer they got. I don't like their solution as much. I think my solution's a little cleaner. So good. That's an example of a contest math problem, which I find actually really quite fun to do. It's puzzling. You could say there's a lot of steps. We needed to know this factorization for sum of cubes. We had to know trig identities for the sine squared stuff, and we had to do this intermediate step to get the cross term. But that's good. That's one. If you could do 20 or 25 problems like that within the span of a few hours, then you'll go on to compete in ARML, which is quite prestigious. Okay, so I'll end that video here.